Welcome to JCE Connect. In the previous class, we were discussing about the automatic flushing tank, uh, where it is used for cleaning the debris that is present in the sewers. If I say the debris, it may contain silt, sand, of course, where um, the flushing tank is useful where the self-cleansing velocity is not well maintained. So then we'll move on to the oil and grease traps. This is used for uh, removal of oil and grease that is present in the sewer. So if how exactly these oil grease are present? Of course, the kitchen wastewater or from the um, hotels as well as the restaurants. Um, it consists of a lot of oil. Suppose if if the small scale industries like garages, if they are discharging their wastewater directly to the sewer systems, then you may expect the grease as well as smoky fats also. If these oils and the greases are not removed from the sewage, they will stick to the interior surface of the sewer and it will start clogging. What will happen is that once it is sticking onto the inner surface of the sewer, then it is very difficult for the removal in further cases. Automatically, the durability what we are talking about um, of the sewer materials are going to be damaged, or um, it is going to be repaired at every time. So sewage from the garages, particularly from the floor drains and the wash racks, contains oil, mud as well as the sand. The principle on which this oil and grease trap work is, we know that the oil and grease is being lighter than water. Always it will float on the surface of the sewage. It is very easy to remove this oil and grease from the sewage. Then that kind of arrangements has to be made. The outlet is provided well below the surface so that the water is excluded from the oil and the grease. Once it is floating onto the surface, it is very easy to remove the oil and grease. If silt also has to be excluded, it is done by providing the outlet at the top. We'll see that diagram, how exactly the things are there. The silt always, it has a tendency and it will settle at the bottom. And the silt free water can be drained through outlet. Then if you see the arrangements are like this. This is whatever the arrangements, normally they will make it in the sewer distribution network. Here you can see at the top portion, yellow, this portion, it is nothing but the fat, oil and grease. Then this is what the inlet, assume that this is the inlet which is coming and which is joining here Always the fat oil, it will floats on the surface, and this is a sludge which is having the highest specific gravity. That is what we are talking about, silt and sand. Of course it will settle here. Then you can see the arrangements here on the other side, where it will move towards this side. Then whatever it is there, it will be taken out from this side to other side. So once it is separated, it is very easy to remove. In some of the cases, if some of the mixed type of oil is there, then it is very difficult to remove. Suppose assume that if it is in the mixture, assume that if small oil components are there in this portion. So then some of the techniques like using of the ether, sometimes they will do it. Ether, they will mix it with this, and once you mix it, whatever there in this portion, it will automatically float on this portion. If it is uh, floating without ether, then no need to add the other ether components. So if it is not floating, or if it is mixed with the silt or the sand, then it is very easy to separate it out with the help of the ether compounds. Then it will be separated out from this side. So then we'll move on to the regulators. Sometimes, if I say one more type of system is there, that is a DAF system, that is dissolved air flotation. Dissolved air flotation means in some of the cases they will use this kind of systems where the air is blowed from the bottom portion. Air is blowed from the bottom portion. Once this air is blown from the bottom portion, so it will create the bubbles. Once it is going to bubbles, automatically whichever if the silt or sand, which is assume that this is a silt particle, then on the surface of this, if the oil is attached, then once the air is blown to this, so it will separate it out like this, and whatever the top portion is there, it is removed. It is removed. That kind of systems also they will use where the importance for the oil and grease can be trapped. So in some of the sewage systems, regulators are used. A regulator is a device that diverts the sewage flow from one sewer to another. Means it is going to regulate the flow from one section to the other sections. The regulators usually go into the action when the sewage flow reaches predetermined amount. It may then divert all the sewage or only that part above the predetermined flow at which it begins the function. So regulators are used where the combined sewer discharge into the interceptors. So the interceptor takes the dry weather flow, but the storm water is diverted into sewer, which flows to the nearest water course. Of course, these are regulators are more common in, we already discussed, that is in combined. It is used in combined flow. Combined flow in the sense your sewage and the storm water is going to mix. If that is the cases, what will happen is that normally during the rainy seasons, these play a very important role. During normal dry weather flow conditions, um, it is very easy, that much of regulation is not required. But whenever the combined flow, that too in rainy seasons, if the flow is maximum, so it is better to divert with the help of the regulators, so that the flooding can be stopped. So the regulators have its own importance in um, controlling the flood in the cities. So then, normally two kinds of regulators are provided. One is the side flow Vr and overflow Vr arrangements. Sometimes what will happen is that this is also one kind of system where the regulators can act uh, like the flood controlling devices. Assume that if you consider this side flow Vr, so assume that this is the circular section of the sewer, which is of combined sewer. So assume that it is totally reaching to the top. Once if it is totally reaching, then make an provision like separate pipe, so that whatever the, if it is flowing above this, it has to reach to the one more type of sewer where it can be diverted. This kind of arrangements also we can call it as the regulators. So regulating regulating the flow, regulating the flow in the sewer network. Sewer network. Then one more type, that is overflow Vr arrangements. Sometimes what will happen is that this is what assume that you have sewer is there. Suppose if it is reaching at the top, then automatically what will happen is that here one provision they will make it like this. So then automatically it has to rise. Then they will make one separate arrangements like this at the top of the bottom, and it will go into some other type of basins, or we can call this as a relief sewer. Relief sewer like this. That is nothing but overflow Vr arrangements. So then inverted siphons, uh, these inverted siphons are used when uh, where the gradient of the sewer line is very low, and at some portions, and the other portions the gradient is very high. Normally we discussed two very important aspects in maybe you have studied in hydraulic machines or fluid mechanics, that is hydraulic gradient line and total energy line. So hydraulic gradient line is nothing but it is a flow along the pipe, and as the flow go on decreasing, the your hydraulic gradient line is also go on decreasing. Suppose assume that we have a section like this. So as the flow go on decreasing, automatically your hydraulic gradient line is also go on decreasing. Suppose if it is moving constant, then your hydraulic gradient line is also, for example, this is what the flow. Suppose if it is maintaining a constant, then your hydraulic gradient line, it is remains constant. Just for the understanding purpose, hydraulic gradient line is nothing but it is the flow along the pipeline. So whenever sometimes the distribution of the line, sometimes it will be up like this. It will be up like this. Again it will rise. Again it will rise and it will reach like this. If that is the cases, what will happen is that the flow, whichever it is there, it will come and it will join here and it won't rise. After this, it won't rise. So if it don't rise, then what will happen is that we require some siphonic action that has to be performed at this position. So then, if this is the things, then we have to provide the inverted siphons. The pressure in the sewer line will be greater than the atmospheric pressure. So if that is the case, you have to provide the siphons. On the other hand, inverted siphons are the depressed sewers that runs under full gravity flow at a pressure above the atmospheric pressure. The profile being depressed below the hydraulic gradient line. So inverted siphons are used to pass the sewer lines under obstacles such as buried pipes, subways, stream beds. The pipe used must be above the withstand internal pressure, as the high velocities as possible should be maintained with zero point 0.9 meter per second. We already discussed that we have the velocities like 0.45 meter per second to zero point 0.9. So then in these cases, we have to go with 0.9 meter per second. So inverted siphons may consist of one, two or more pipes depending upon the amount of flow and head available. So you can see this is the construction of the inverted siphons, where you can see the construction of this inverted siphons. This is the overall construction, and here the detailed dimensions are also given. Very rarely they will construct like this. Wherever you have bridges or some of the obstacles, it will be there. Assume that this is the sewer line. Suppose assume that you have a road is there. Suppose if you want to cross this road, so then they will go with the uh, siphonic actions so that it can be joined. Then the lamp hole we will discuss in the next class.